MS Ramaiah University of Applied Sciences.
Hi students, let us discuss heat balance test on IC engine. Significance: to evaluate efficiency, to evaluate heat added and heat rejected in different forms, to study characteristics, to improve performance, to calibrate and draw performance maps, to program engine control units. Multi-cylinder petrol engine is used for automotive application. Power is defined as the rate of work done and is equal to the product of force and linear velocity or the product of torque and angular velocity. Power developed by an engine and measured at the output shaft is called the brake power BP. Measurement of power involves the measurement of force or torque as well as speed. The force or torque is measured with the help of a dynamometer and the speed by a tachometer. Power P is equal to 2 pi Nt by 60 into 1000 kilowatt, where T is torque in Newton meter and N is engine speed in revolutions per minute. Specific fuel consumption SFC is defined as the amount of fuel consumed for each unit of brake power developed per time. It is given by the equation as shown. Heat input or heat added to engine Qin is the heat energy input to engine in the form of chemical energy. Qin, that is heat input, is equal to mF into CVF kilowatt, where mF is mass flow rate of fuel and CVF is calorific value of fuel. Thermal efficiency is the ratio of the output to that of the chemical energy input in the form of fuel supply. Efficiency is equal to P by Qin in percentage, where P is power and Qin is the heat input. The formulae used in this experiment are as shown. The block diagram shown represents simple layout of multi-cylinder SI engine test rig with exhaust gas calorimeter. Measurement techniques: fuel flow measurement. Measuring volume flow and then correcting it for specific gravity variations is quite inconvenient and inherently limited in accuracy. Instead, if the weight of the fuel consumed is directly measured, a great improvement in accuracy and cost can be obtained. Airflow measurement. Air box with sharp-edged orifice plate. Water or coolant flow measurement. The sensor sits in line with the water line and contains a pinwheel sensor to measure how much water has moved through it. Integrated magnetic Hall effect sensor that outputs an electrical pulse with every revolution. Temperature measurement. Thermocouple based temperature measurement. Engine speed measurement. Accurate and continuous measurement of speed. A magnetic pickup placed near a toothed wheel coupled to the engine shaft can be used. Magnetic pickup will produce a pulse for every revolution, and a pulse counter will accurately measure the speed in revolutions per minute (RPM). Torque measurement. It consists of a stator on which are fitted some electromagnets and a rotor disc made up of copper or steel and coupled to the output shaft of the engine. When the rotor rotates, eddy currents are produced in the stator due to the magnetic flux set up by the passage of field current in the electromagnets. These eddy currents are dissipated in producing heat, so that this type of dynamometer requires some cooling arrangement. Torque is measured with the help of a moment arm. Load in internal combustion engine testing is controlled by regulating the current in the electromagnets. With this brief introduction on heat balance test on IC engine, we will start the experiment.
Hi, let me show you how to conduct the heat balance sheet experiments. Now let me explain you the various components of the 4-cylinder petrol engine. So first component of this equipment is the control panel, then 4-cylinder water-cooled petrol engine. This is the 4-cylinder water-cooled petrol engine. This is connected via shaft to the eddy current dynamometer. Then we are having the fuel tank, and then we are having the airbox. This is the water cooled engine. The engine is cooled by the water. The water line is connected to the here like this way. You can see here to the main water supply here. Also the eddy current dynamometer here. This is also a water cooled eddy current dynamometer. This is also connected to the water supply line here. And whatever the exhaust gases are coming out of the engine, this is passed to the exhaust gas calorimeter here. For this also we have to supply the water here. So for that purpose there is a water line here. Various sensors used in this experiments are, first one is the RPM sensor, second one is the load cell to measure the torque applied to the engine. This sensor is used to measure the water flow quantity to the engine, and this sensor is used to measure the water flow quantity to the exhaust calorimeter. Now we will see on the temperature probes. This is the thermocouple which is used to measure the water inlet temperature to the engine, and this is the thermocouple which is used to measure the water outlet temperature from the engine. These two are connected to the engine. This is the thermocouple which is used to measure the air inlet temperature to the engine. Then this is the thermocouple which is used to measure the exhaust gas temperature from the engine. Then this is the thermocouple which is used to measure the exhaust gas temperature from the calorimeter, and this is the thermocouple which is used to measure the water outlet temperature from the calorimeter. Air pressure is measured using the manometer that is connected to the control panel. Okay, and the fuel supply to the engine is measured using the load cell which is connected at the bottom of the fuel tank. Engine control panel consists of engine on indicator, then oil level indicator, then cylinder cutoff switches, then ignition on key, then accelerator knob, then we are having the clutch to connect and disconnect between the engine and the dynamometer. All the sensors from the engine are connected to the display unit here. In this unit it consists of torque indicator, speed indicator, then multi-channel temperature indicator, then high temperature indicator which is going to measure the exhaust gas temperature, then fuel rate indicator, then flow rate indicator from to the engine, then we are having the air consumptions indicator, then we are having the one more flow rate indicator which will measure for the calorimeter, then we are having the loading switch, and we are having the load controller. To conduct the experiments you have to follow the procedure like this way. First, switch on the display unit. Supply to the eddy current dynamometer has to be switched on here. Then water supply to the engine has to be supplied here. Both the water is flowing in the channels here. Now the flow rate to the engine has to be set to around 160 cc per second, and to the calorimeter has to be set around 40 cc per second. Now to conduct the experiments, First, switch on the ignition key. Then connect the dynamometer to the engine using the clutch. Then give the acceleration through the accelerator pedal here by giving the 3 rotation here. 1, 2 and then 3. Now come to the control panel. Now apply the loading. Then now apply the 10 Newton meter torque load here by adjusting the loading control here. Gives the first set of reading. Similar way, conduct the experiment for two more different loading as 15 Newton meter torque and 20 Newton meter torque. This completes the heat balance sheet experiments.
Readings from test rig is as shown. The heat balance sheet is as shown. This completes the experiment. Thank you.
At MSR UAS, we spark your imagination unlike any other.